Hello, this is Mary Went, and this is a video on how to create data displays. So the first thing to talk about is the purpose of a data display. You always want to consider the reason for doing what you're doing. Data displays are used to help readers visualize your information, possibly complex data. So you want to ask yourself some questions before you choose to use a data display. You want to think about what you hope to prove with the data that you're including, how looking at the data visually will help to make your point. Neighbor has a motorcycle, sorry about that. And what the most crucial point is that you need to convey with the data display that you are actually including. So some things to think about before you actually choose a data display. So I want to walk through some different kinds of data displays that you could possibly use. The first one is a pie chart. I'm sure you've seen these before and you know what they are. Pie charts are always used to show parts of a whole and represent percentages in comparison. So you always have to have 100% of whatever data group you're working with, and you always want to make sure that you label your pie slices. I do not recommend a legend where you have them over to the side. You want the labels to be directly next to or on top of the pie slices, and you always want the numbers underneath. The numbers are very important. If you look at this particular pair of slices right here, notice this one's 11 and this one's 13, but size-wise you can't tell the difference. So those labels are very important in your pies. Another kind is a bar chart. This is a simple bar chart. This is when you only have one data group. This is not when you're doing any kind of comparing. Mostly these are relatively simple, probably not ones that you'll use. You'll probably be more likely to use a complex bar chart, which is used to represent more than one data group and is used for comparisons purposes. So by having the two bars next to each other, you can compare the District of Columbia to the United States and see the differences, and it makes a visual statement. I included this one just because you want to turn your display 90 degrees when you have these long x-axis labels, because they become difficult to read if you have them the other way. So because they have to go this way like this, and then they get weird and hard to read. Another kind is a line graph. This is if you have several data points. So instead of putting them in a whole bunch of bars, you just put them in data points and turn it into a line graph. It shows progression of whatever it is that you are displaying, so relationships to one another. And you can do a complex line graph where you have two sets of data and you compare them. So this one you can see the dark blue is the number of counties and the light blue is the number of registrations and how they crossed each other. A scatter plot is also if you have a lot of data points, and you can plot them if you know how to do the math and you want to find out if there's a regression. Please don't use these if you don't know how to do the math. Some computers will do it for you, but you need to understand what you're doing. However, if you do have enough data points and you want to plot them and you think there is a regression, this can be a very persuasive tool. There's also this idea of a data map, which can geographically or spatially represent some data. So these can come in handy if you have something that is can be seen in space. Okay, I just got a few bad data displays I pulled off of the internet, some from a couple of papers that I thought I'd show you, just to highlight some of the things you don't want to do. This is one of those that has labels on both sides here. My pen stopped working. But notice that this label on the left and the label on the right are not, you can't tell, like right there it goes on, it's working again. You can't tell if this number is this or if it's this because it's just here, right? So that's one thing you don't want to do. This is also a good example of what happens when you have these long labels and they're on the bottom. Also, you notice that the scale is bad because the blue, which represents groundwater, can't be seen there. You can't tell what the numbers are. And this is really confusing. 1991 and 580. I don't even know what those numbers are. So bad data display there. This is also a bad one. These, you can do these really easily and they look kind of cool, but they're not helpful. And if the reason for your data display is to help your reader understand your information, this one isn't going to do it. So notice that some of these, it looks like there's probably something down there, something down there. We can't see those. Also, there's really no way to know where this lines up. I don't know if that's an 8 or a 5 or a 3, right? We can't tell how they line up. It's really hard, like if I wanted to find September in Seattle, I'd have to count down 4, 1, 2, 3, 4. So it'd be this one. I don't know what the numbers would be. So that's why these, you just, even though they look cool, you want to avoid them. This is an example of when pie charts go bad. The pie charts, notice they're not labeled. They're using the big pie to represent the same number and the middle pie, as though 18,000 car sales were made in all of these states, right? But then you look at the different pies, you can't see what the numbers are. So pies without labels are pretty pointless. And this, while this data display, you think, well, this looks kind of nice. We have the data here, and then we have the little display down here. But there are several problems with this, and I want to point them out. One, notice that there are no labels. So 5, 10, 15, 20, we don't know what those represent. I'm going to guess that they represent this number right here, because it's the only one that fits. But notice the scale is bad. So this is also a problem of scale. If this is 5 and the numbers are 3.1 and 3.4, why would you go to 20, right? You'd want the scale to go from 1 to 5, or maybe from, within 2 and 4 or something, because those numbers are so small. But here's the most important point about why this is a bad data display. Your readers don't need a data display for these numbers. The numbers are simple. So if you look at the numbers, looking at them visually does not help them understand those numbers in any way. So bad data display there. This is from a paper, a student who was required to use a data display. And I thought, wow, this is my favorite data display. People who disagree and agree, 50% both ways. And then I turned the page and this was the next page. The people who agreed with the next question was 100%. And the fact is, folks, your readers don't need a pie to visually understand 100%. And this one I just pulled off the internet because it's so complex that pretty much nobody can read this. I just thought it was kind of lovely. Okay, so the next thing to understand is matching your graph to your purpose. So you want to think about the different kinds of data displays and which one you want to choose for the data that you have. So I just made up some data. Weekly beverage consumption. This is in ounces, by the way. So I picked 4 different beverages, threw some numbers in a chart, and threw it into Word. Let's see what it came up with. So I tried it as a line chart. And it does show change across time, but it doesn't give us visually, I don't look at this and think, huh, okay, I don't know what to make of it. I guess there's this convergence here. So on Thursday, the same amount is of those 3. It really doesn't tell us much. So I put it in a pie. If I put it all in a pie, if the purpose is to reveal trends in overall consumption, a pie chart really doesn't work well. It would only be to use percentages. So if my goal was to show which ones were consumed the most, this might work. It shows that water and soft drinks are consumed the most. But other than that, it's not very visually helpful. I can be told this without actually seeing it in a pie. Bar chart helps a little bit more. So when you look at the bar chart, what it does is it puts each beverage in that particular day next to one another, and it helps you see both the movement in the amounts and the amount per day. So a bar chart is a little bit more helpful. But check this out. This is the best one. Look what happens when you do a stacked bar chart. This stack bar chart shows you how much, shows you the total per day, so you can easily see which day consumes the most. And it also shows you which beverages are consumed the most each day as well. So a stack bar chart really becomes the most helpful to help visualize the information. Okay, so creating your data displays, you can do this right in Microsoft Word. So you open Microsoft Word. In your new document, you're going to select Insert, and then Illustration, and then Chart. Some of them also have, I think up here, just a little icon. Shoot, no, my pen's not working again. I think it's up at the top. There's a little icon with a little bar chart. You can click on that as well. And then you choose the display type. It'll give you a list. Pick the one you think you're going to want to use the most, and then put it in there. You're not married to it because you can change it after you have put in your data. And then a data entry table will open and you enter your data. It'll automatically create the chart as you enter the data. Okay, so some things to do when you're creating your data display. After you have entered the data, you want to make sure you click the plus symbol, which is right here next to your chart there. And then you want to make sure you add all of the elements to your chart to make sure that you are displaying everything. So you want to choose axes, axes titles, chart title, data labels, grid lines, and legends. You want all of those to make sure that they are showing in your data display. Fill in all of those elements. Notice a couple of things when you're putting in your data. Column A here becomes your x-axis, and then row 1 becomes your legend, okay? And then column A will be your non-numerical data. So as you're entering your data, that can help you think about the kinds of data you're going to put in and where it goes. So here's the anatomy of a chart and all the things that you want to make sure are showing. You want to make sure your title is large, and it should be very comprehensive. By the comprehensive, I mean every single detail that you could possibly imagine. So this one in particular, breakfast food eaten per week by kids under 5 in households with income below the poverty level. So all of that information is in the title. Usually want to go for maybe a 14-point font if your paper's in 12-point font. Be sure your legend is visible and is really close by so that people can tell. Make sure you have these labels, right? Even if you think it's obvious. So let's say this said Monday, Tuesday, Wednesday. You still want days of the week below that, okay? Especially on this side. Number of times per week they consume these foods. Once, twice, 3 times, right? You need to have those labels on there. Remember too that this is your x-axis down here. Non-numerical data goes here, and the y-axis is always your numbers. And every data display must have a commentary. This is a must. I'm requiring it. You should do it anyway. So what you have to do is add commentary in a paragraph. It should be a separate paragraph, and it should be in the same visual space as your display. People need to be able to see the display and read the commentary at the same time. So whatever you have to do to make that happen, do it. Maybe you need to move your paragraph so it's both on the same page, but you've got to make sure that happens. Using tight formatting will help your data display do this here, where your text can wrap around your data display, and then you can click on the data display and move it around in your paper without disrupting your paper. This is the way to make sure that it doesn't take up your whole page and it doesn't mess with your actual paper itself. Okay, so the 3 parts of a data commentary. Every data commentary has 3 parts. So for every data display that you put into your paper, you must have a data commentary, and each commentary must have 3 parts. First is the summative statement, and it is basically the title in sentence form. So you want it to be very comprehensive statement telling us what it is we're looking at. Then you want a highlighting statement, and that highlighting statement is going to draw attention to the one thing that you think is the most important part of your data display that you want to discuss, and then you explain how that data that you have highlighted matters. So you want to explain why it's important, why it's relevant, and what its implications are. So, for example, let's take this same data display about breakfast foods eaten per week by kids under 5. And this would be the first sentence of your paragraph, okay? First sentence of your paragraph, figure 1 shows, and you're going to label this figure 1, right? Figure 1 shows the type of breakfast food eaten per week by children under 5 years of age in households with an income below the poverty level. That is the first sentence of that paragraph. The next sentence will be your highlighting statement. It'll sound something like this. Notice that the number of times children consume cereal increases as the number of children in the household increases. So what I want to draw attention to is this right here, how this increases. That's what I'm trying to draw my attention to of my readers, is to that progression right there. So that's my highlighting statement. Then is the explanation. Because the cost of cereal is considerably lower than the cost of eggs, we can see that households with little money are capable of making food choices that help maximize their available resources. This would also indicate that when money is scarce, parents will make food choices based on value rather than nutrition. All right, so this is explaining why I am showing this data to begin with, why I'm highlighting this particular curve, and why all of this is important. So some last thoughts. Choose your data type, your data display carefully. Make sure it's appropriate for what you're doing. Make sure everything is labeled. No matter what kind of data display you want it to be very completely and thoroughly labeled. Make sure you have a complete commentary for every display you include. So if you put 3 data displays in your paper, you have to have 3 data commentaries. If you put 10 data displays in your paper, you have to have 10 data commentaries. So think carefully about how many of these you're going to put into your paper. And be sure you're using a display to help readers understand complex data or data that is clearer with a visual aid. Please do not resort to overly simple displays that are unnecessary. Please don't give me those pies with 50% or those bar charts to show something that is very simple to understand without a data display. This is when you do that data comparison, you compare sets of data, and you show it visually. All right, that's it for data displays. Have a wonderful day.